Most honored participants, the committee for this academic week has requested that each day I give an introduction to the topic that will be discussed later from a scholarly perspective during the course of the same day. This decision was based on the view, perhaps, that the various branches of science and of life could be enriched by the perspective of anthroposophy. In that sense, I would like to ask you to take these first lectures of mine only as introductory comments to the discussions of each particular day. With regard to the perception of anthroposophic research methods, it has always been most astonishing to me to realize the resistance demonstrated toward anthroposophy, especially on the part of philosophy and natural science, although I am not saying only on the part of natural science. The reason for that resistance is apparently the belief that in some implausible, confrontational way, anthroposophy contradicts the methods of natural science, which have been established as extremely productive in the course of the last few centuries, particularly during the 19th century. This belief seems to me one of the things concerning anthroposophy that is most difficult to understand in our times. It is precisely those productive methods of research established in natural science that anthroposophy wants to develop further. However, if we want to understand anthroposophy, we should be able to assume that in the idea of, quote, further development, close quote, there is something more than what today people usually call further development of theoretical views. Development of theoretical views means to most contemporary people that this specific way of analogical thinking, parenthesis, particularly with regard to theoretical paradigms themselves, if I may put it this way, close parenthesis, remains the same, even if the respective systems of thinking are transferred to other areas of universal phenomena. For example, when we are confronted with inanimate, inorganic nature, we need to establish certain analogies, particular frameworks of thought, a sum of interconnected thoughts, as a basis for defining theories of these inorganic or inanimate phenomena in nature. Then, when we are trying to understand a different set of phenomena, for instance, organic natural phenomena, we assume that we can simply expand that very same system of thoughts. We try to use the same causal understanding that is so productive in the area of inorganic matter in the realm of living beings, and to explain them with the very same concepts. Hence, from a conceptual point of view, we are trying to turn the area of living beings into the same functional system of causalities that we are forced to establish when dealing with inanimate or inorganic nature. We simply carry the paradigm we have adopted from inanimate nature over to organic nature. This is what we usually understand today under the expression expansion of ideas or of theories. What anthroposophy means by expansion of ideas, however, is quite the opposite. Anthroposophy should support a certain independent growth or metamorphosis of ideas when we move from one area of universal phenomena into another, so that we do not simply transfer to living nature what we have learned only from inorganic phenomena, even though it may seem logical. Thoughts concerning one particular area have to take different forms when they appear in another area, as comparably things in the living world change when they grow, or when they go through metamorphosis, and often become unrecognizable in the new form that they have taken. What remains always the same throughout all areas, giving the entire scholarly worldview a monistic character, is the way we relate to what we could call scholarly certainty, a concept fundamental for scholarly beliefs. Only those who are able to test why they cannot come to any satisfaction of causal human needs, if I may repeat the phrase of Dubois-Reymond, if they use the same concepts they apply to inanimate nature, only those who really come to know this inwardly would be able to transfer their experience to a different way of making arguments about the living world while using completely different concepts, even if these are only metamorphoses of earlier concepts. The position the human being takes within the world of scholarship and science is definitely monistic throughout the entire scientific worldview. Misunderstanding this usually leads to the fact that people tend to ascribe a dualistic rather than a monistic character to the scientific anthroposophic worldview. The second reason for misinterpretations is phenomenology, which anthroposophy must acknowledge, particularly with respect to natural science. Precisely in the area of such productive scientific developments, at the time when the great natural scientist Virchow gave a speech about replacing the philosophical worldview with a scientific one, we learned that the productive concepts of inorganic matter, which, looking from an historical perspective, we have rightfully established, have in fact substantiated a certain rationalism in natural science. So, the era that, on the one hand, with regard to the external world of facts, was strongly focusing on empiricism, ended, on the other hand, with a powerful rationalism when scientists moved from observation to explaining the facts of nature they discovered through experience. In contrast, anthroposophy represents a viewpoint that, at least for me, if I may make this personal remark, is based on Goethe's understanding of nature. Anthroposophy is established on the foundation of a phenomenological understanding of nature. In modern times, this phenomenology was, in a way, explained again by Ernst Mach. The way he explains it makes it look as if it provides very productive viewpoints, as long as we stay within its parameters. We can find Goethe's explanation in his statement that, quote, "the world of phenomena is a theory in itself, and we do not need to take another step toward creating artificial theories." Close quote. The blue of the sky is a phenomenon in which we do not have to look first for hypothetical, assumed explanations of the meta-phenomena in a rationalistic way through simple thoughts. This is how Goethe came to the realization of what he calls the original phenomenon. Many of Goethe's ideas concerning natural science have certainly been outdated in the very creative 19th century. Nevertheless, we could say that the methodology or the way of thinking that Goethe introduced into natural science is not only still relevant now, but it also, in my view, is not yet fully understood. I do realize that many or almost all the details of Goethe's explanations about natural science were outdated in the course of the 19th century. And yet I would like to refer to something I said before the end of the last century about Goethe's view of nature, that Goethe is both a Copernicus and a Kepler for natural science. I still repeat that statement today, because I believe that the statements that follow are justifiable. How do we eventually come to a view of nature in the particular area in which the 19th century achieved so much? Parenthesis, I am not able to give other outlines for the things I mean to explain, except those of history. Close quote. Close parenthesis. All the achievements of the 19th century in natural science led back to the application of mathematical methods, with almost no exception. A mathematical way of thinking was fundamental, even in those cases that did not directly concern mathematical methods, but where other kinds of causal thinking were used instead, and where other theories were established. The following facts are indicative. We have seen that during the 19th century, certain branches of natural science were explained in a rationalistic way by using mathematics. We all know Kant's statement that in each science there is only as much certainty as there is mathematics. Now, we certainly cannot bring in mathematics everywhere. Causal explanations offer more possibilities than the producing of mathematical concepts. However, explanations based on causality do follow the patterns employed in mathematical concepts. When Ernst Mach aimed at an overview of this system of concepts from a phenomenological viewpoint, he had to look back at the concept of causality as well, and at the way this concept had developed in natural science during the 19th century, to find the particular content of this concept. Finally, he concluded that if he could think of some effect and its cause in connection to each other, then this thought would represent nothing but the concept of a mathematical function. For example, if I said x equals y, having in mind that x is the cause and y the effect, then I have brought everything down to the concepts I use in mathematics when I produce a function. Thus we can see from the history of science how we have transferred the concepts of mathematics into natural science. Goethe, of course, is rightfully seen as a non-mathematician. After all, he defined himself as such. However, considering him simply as a non-mathematician will lead to new misunderstandings. We would then assume that Goethe could not achieve a lot in the area of mathematics, and that he was not particularly capable of solving the mathematical problems that existed at the time. And in fact, we should admit this. I even believe that as a person, Goethe would have not had much patience for solving particular mathematical problems, especially if they were about algebra. We should admit this too. Nevertheless, as paradoxical as it may sound, Goethe was in a way more of a mathematical thinker than many mathematicians. He had a fine sense of the nature of mathematical processes, of the nature of producing mathematical concepts. He appreciated the kind of thinking that remains hidden in the inner soul process and in the content of imagination when concepts are constructed. When we construct mathematical concepts, we overlook our own internal process. A simple example would be the common proof that from Euclidean geometry of the three angles of a triangle, which add up to 180 degrees. If we draw a line across the top parallel to the baseline, and we observe the newly created angles, whose total as alternate angles is equal to the total of the other two angles of the triangle, the one in between remains the same, we can see that those three angles at the top add up to 180 degrees, or that their total equals the total of the three angles within the triangle. In any case, we overlook this fact. Read that again. In case we overlook this fact, we still have mathematical proof. But at the same time, we have something that shows that we could be completely independent from external observation and could fail to see things in our internal process of constructing. Then, if we have an external triangle, we realize that we can prove through external facts the same thing that we previously failed to see internally. This is true for mathematics in general. Everything appears in a way that does not require sense perception for us to come to what we call proof. At the same time, everything that we have figured out internally could always be proven bit by bit externally too. Goethe thought that what this special quality of mathematics represents is eminently scientific in character. And in that sense, he really did have a mathematical mind. This view was also the basis of the famous conversation about the method of scientific observation that Goethe and Schiller once had at the height of their friendship. They were both listening to a talk given by the natural scientist Batch at the Jena Society of Natural Science. When they were leaving, Schiller made a comment about what they had just heard. He said to Goethe that this was a way of looking at nature in which one only takes things apart, and that it would never lead to anything that is whole. We can imagine that Bach had simply examined natural objects individually, one after the other. As was typical for the scientists of the time, he had failed to produce an argument that could have led to an overall view of nature. To Schiller, such an approach was unsatisfactory, and he expressed his disappointment to Goethe. Goethe told him that he knew how to bring some unity, some wholeness, into the way we look at nature. And with a few brief strokes, as he himself describes it, he began to outline the original plant in the way we could imagine it internally, not as it is manifested in a specific plant that has roots and stem, leaves, blossoms, and fruit. In my introduction to Goethe's title Naturwissenschaftliche Schriften, parenthesis, works concerning natural science, close parenthesis, which I wrote in the 1880s, I tried to repeat the drawing that Goethe had sketched for Schiller on a piece of paper at the time. Back then, Schiller looked at the drawing and said something based on his own way of thinking. Quote, "This is not an experience. This is an idea." Close quote. What Schiller meant by this was that one could draw something like that only if it comes out of one's own imagination. This was something great as an idea, as a thought, but it had generally no physically existing source. But Goethe did not understand what Schiller meant, and ended the conversation summarizing what they had said so far. Quote, "If that's so, then I see my ideas with my eyes." Close quote. What did Goethe mean by that? He did not spell this out, but he meant that if he tried to draw a triangle, its angles would naturally add up to 180 degrees. No matter how many triangles he looked at, what he had constructed internally in this one triangle would apply to all triangles. Hence he made a conclusion based on something which came from inside himself, and which now fully applies to his experience. This is how Goethe wanted to draw the original plant, in a way similar to the original triangle. And this plant was supposed to show what we could find in any specific plant. In the same way that the angles of any triangle add up to 180 degrees, given that we have the original triangle, the ideal form of the original plant should be found in any particular plant throughout the full range of all plants. Goethe meant to shape science entirely in accordance with such a perception. In essence, though he never succeeded, he wanted to shape organic science using the same way of thinking that had proved to be productive in inorganic science. This became particularly clear when he wrote from Italy that he kept developing the idea of the original plant further and further. In this context, he said that looking at the plants in southern Italy and Sicily, at the variety of the flora there, he came to realize better and better what the original plant is. He thought that there must be some species that carries in itself the potential of all actual plants, a species that could vary in its form, that could adopt a variety of shapes, parenthesis, an elongated leaf or a leaf with a different form, close parenthesis, a species in which either the blossoms or the fruit would develop more, and so forth, as a triangle could be obtuse or acute. Goethe wanted to find a species that was a model for all plants. It is completely wrong to insist, as Schleiden later did, that with his original plant, Goethe meant an actual specific plant. This was absolutely untrue, as untrue as it would be to insist that a mathematician who speaks of a triangle has a certain physically existing triangle in mind. Goethe was talking about an image that could be created internally, but which could nevertheless be verified anywhere in the external world. This is why I see Goethe generally as being mathematically minded. He was more mathematically inclined than the astronomers. And this is what really matters. This is what made Goethe say to Schiller, quote, "In that case I see my ideas with my eyes," close quote. He saw them with his eyes because he could find them everywhere in all phenomena. He did not quite understand why some things are perceived only as ideas, because when he was producing ideas, he was in complete harmony with experience, exactly as the mathematician feels that he is in harmony with experience when producing mathematical ideas. However, I have to say that consequently, through an internal logic, this led Goethe to a mere phenomenology. In other words, he was not looking for anything else beyond appearance. And most important, he was not trying to create a rationalistic world of atoms. Now, in mentioning phenomenology, we come to a subject that has had many arguments directed against it. To me, the arguments are all based on misinterpretations. We are talking primarily about the fact that we consider a phenomenon to be anything that the external world offers to the senses, or anything that is part of experience or of an experiment. Goethe, and with him the entire scientific phenomenology, is trying not to jump from the sensory phenomenon directly to some atomic process hidden behind it. Rather, Goethe focuses primarily on the purely sensory phenomena and on the unique elements of sensory facts, without drawing a connection to anything behind them. What he searches for are simply elements in the phenomenal world that are related to each other, and he tries to find the connections between them. I can fully understand where the respective misinterpretations come from, and how easy it is to see such phenomenology as unproductive. For example, one could say that if we limit ourselves to simply describing the interconnections between sensory phenomena, if we look only for the simplest phenomena in which the processes are most easily comprehensible, and which Goethe calls original phenomena, then our approach will never lead us to understanding the very productive discoveries of modern chemistry. One could ask how we could deal with atomic weight relationships without any understanding of the world of atoms. In this case, one might want to ask a counter-question. If we become aware of a given phenomenon, would it be necessary to distance ourselves from it? We certainly would not have to do this. Even when we compute atomic weight relationships, we still have to deal with a phenomenon, namely with weight relationships. Would it bring us any further to try to explain the same weight relationships which are expressed in numbers in a purely rational, intellectual way through the fact that from the atomic weights we produce certain molecular structures? We could ask that question, couldn't we? To summarize, from Goethe's perspective, this is all about the fact that we should stay within the realm of phenomena. Here I would like to give a very simple example. Let us assume that we are given a written word to look at. What do? Well, if we have never learned how to read, we will stare at it as if it is something inexplicable. But if we have learned how to read, then, unconsciously, we will put together the different forms of the letters, and we will experience the meaning of the word in our soul. One thing we certainly would not do is try to explain the meaning of the word on the basis of the form, say of W, considering the beginning of the upward stroke and then the one going downward, thinking that in this way we will discover something profoundly significant about that letter. In other words, we will be reading rather than trying to explain things through assumptions. This is how phenomenology wants to read. It wants to stay within the context of phenomena, and it wants to learn how to read. And if it has to deal with a complex of phenomena, it does not want to go back from that complex to the small atomic structures. Hence, this is all about accepting the realm of the phenomenal, and about learning how to read its own internal meaning. Such an approach will bring us to a kind of natural science that will contain nothing rationalistic constructed beyond the phenomena. Instead, simply by the way it views phenomena, the science will find certain regular structures. This kind of natural science will always represent the sum of the phenomena themselves. People will speak in a very particular manner about nature. The laws of nature will be the content of such a manner of speaking. But the phenomena themselves will always be at the foundation of the forms of expression. This is how we can achieve what I would like to call a natural science immanent in the phenomena. This is the kind of science Goethe was seeking. His methods, however, will have to be updated in the light of the progress achieved today. Nevertheless, the basic principle could be preserved. And if we do preserve this basic principle, we cannot but discover something important about our human perception of nature that I would like to characterize as follows. It is understandable that contemporary humanity has established its concepts of natural science primarily on the basis of inorganic nature. The reason is that inorganic natural phenomena are relatively simple. In addition, there are processes of the inanimate world that certainly continue to act when we move up into the realm of organic matter. When we move from the kingdom of minerals to the vegetable kingdom, we cannot say that there are no inanimate processes in the plant. They are included in a higher principle, but they persist in the plant. We are right to explore physical and chemical processes in the plant organism as we would explore them in inorganic nature. In this case, however, we should be able to accept modified, metamorphosed concepts in our paradigms. We should follow how the same processes found in inanimate nature are extended to plants too. Scientists are tempted, however, to follow only those processes that originate in the kingdom of minerals and extend to plants and animals, while failing to consider what else is happening in the higher natural kingdoms. This temptation became extremely strong because of particular circumstances over the course of the 19th century. This is how that happened. When we observe inanimate nature, we feel deeply satisfied in a way, because we can follow the phenomena with a mathematical kind of thinking. I would say that it was completely understandable when in his speech, quote, on the limits of our cognition of nature, close quote, Dubois-Reymond celebrated Laplace's worldview, which, in splendid and rich language, he called, quote, the astronomic conception, close quote, of the entire existence of nature. According to this astronomic conception, with the help of mathematical thinking, we can grasp not only the various phenomena of the firmament and construct with them, as much as possible, one undivided whole, but we can also try to dive deep down into the constitution of matter. We are trying to construct a small universal system in the molecule, where the atoms move and relate to each other as do the stars in the universe. In this way, we construct the smallest universal systems in our small-scale world, and we are satisfied, because in this small-scale world, we find the same laws that apply to the large-scale universe. We know, for example, that the atoms and molecules represent a system of moving particles like the system of fixed stars and planets out there in the universe. This example is characteristic primarily of the intellectual quests of the 19th century, and of the way in which the human need for causality is satisfied, as Dubois-Reymond says. This is simply the result of the desire to apply certain productive methods from the area of mathematics to all natural phenomena. It is also the basis of the temptation to remain at the level of mathematics when we observe all sorts of different phenomena in nature. Unless we speak about those things like amateurs, no one, not even an anthroposophist, would deny that there are logical explanations of all those facts when we look from within the phenomena, and when we try to understand the details, say, about astronomy in this context. No one will disagree with such explanations. What happened during the 19th century, however, was a failure to see the qualitative elements in what the world offers. Rather, people saw only what was manifested, what could be comprehended with the help of mathematics, even though that was all part of the qualitative too. We have to make a distinction. We can certainly admit that this mechanical explanation of the world is completely plausible. No objections. But it makes a difference whether we declare a mechanical explanation to be reasonable in certain areas, or whether we want to present it as the only possible system of concepts, using it to explain every single thing in the world. This is the point where opinions differ. Anthroposophists do not deny or fight against the things that are legitimate. In fact, it is interesting to observe how in discussions, anthroposophy accepts everything that is within legitimate limits. The goal of anthroposophy is certainly not to deny what natural science asserts. The question is whether it is legitimate to try to explain the entire world of phenomena through mathematical thinking. Should we take from the sum of phenomena only the mathematical causal abstraction and treat it as an imagined universal content, as, for example, the former atomism did? Today, atomism has become to a certain degree phenomenological, and up to a point, anthroposophy agrees with it. The problem is that today's atomism is affected by the ghost of the 19th century, and it is in complete contradiction to Goethe, who was not limited to phenomena, but established a paradigm beyond them. If we are not clear about the fact that science now uses only one paradigm, one system of concepts to express the world beyond appearance, and if in confusion we adopt the false view that with this system of concepts we have captured something real, then this very system will actually mislead us. Because of it, we will become dogmatists. We will say that although there are people who want to explain the world of organic nature with completely different concepts, there are no such concepts. We will think we have already established paradigms that cover the world beyond the phenomena. We will think that the world of our concepts is the only one, and it must work somehow with regard to the organic too. In this way, however, we would apply everything that we have established regarding inorganic matter to the observation of organic matter. We would begin to look at organic matter as if it originates in the same way as the inorganic does. Here we have to be very clear. Without complete clarity, we will never be able to establish the foundation for a real discussion. Anthroposophy has no desire to commit the sin of superficiality against any legitimate methods. It does not want to sin against what is legitimate in atomism. However, Anthroposophy wants to clear the way for the establishing of thought systems similar to those established earlier in the study of inorganic matter. Systems that should now be established in other areas of nature too. This could happen only if we say to ourselves, reading is the goal of looking at phenomena. In other words, what I see as the essence of natural laws is already in the phenomena, in the same way that the meaning I discover when I read a word is already in the letters. If I remain with the phenomena lovingly, and I do not attempt to impose some kind of hypothetical thought system on reality, then my sense of science will be free to develop new concepts. This ability to remain free is what we need to establish. We should not restrict ourselves to the use of one paradigm when we shift to examining a different area of nature, even if the first one was rightfully established. We can develop a completely different relationship to thinking if we establish a pure phenomenology, something that would certainly be possible only if we come to the natural laws by interspersing the phenomena that we look at or that we present through experiments with thoughts, and if we make connections between them. In other words, only by remaining within the phenomena can we experience how natural laws that appear in our thoughts are already present in the phenomena themselves. If we accept this idea, it will make no sense to speak about an opposition, in quotes, between subjective thoughts and natural phenomena, at least not insofar as we remain within the phenomena. We simply submerge ourselves in the phenomena, and then in the essence of natural laws, the essence of thoughts is given to us, coming directly from the phenomena. This is why Goethe remarked naively, quote, "Then I see my ideas," close quote, which were actually natural laws in nature, quote, "with my eyes," close quote. If this is our approach to the phenomena in inorganic nature, then it will be possible to transfer it to organic nature, including the scientific study of organic nature. And if we see then that a horse is brown or white, we are not going to ascribe this phenomenon to inorganic colors. Instead, we will see it in relation to something that lives as a spiritual or a soul being in an organism. The created inner organization will teach us to understand that animals as well as plants give themselves a color. In that case, we should certainly be able to observe internally all the details, how metabolism works, for example. But then we do not simply transfer to the organic what we have found in the inorganic. We do not restrict ourselves to one particular paradigm, and we do not rigidly carry our attitudes from one particular area into all others. We keep thinking in a more mathematical way than those who do not want to see concepts metamorphosed into qualitative categories. This is how we validate inner seeing when it comes to the higher realms of natural existence, how we validate inner seeing when it comes to inanimate mathematical constructs. This is only a brief outline of all these things. Further development would show that anthroposophy is really capable of accounting to anyone, including the strongest mathematician, as Goethe put it. This was Goethe's goal when he formulated his idea of the original plant, or with his idea of the original animal, which, however, he did not develop further. This is also the goal of anthroposophy, to take from Goethe's views everything that concerned phenomena in nature, and to move from the understanding of what lives in our imagination to the type of the plant or the type of the animal. I demonstrated already in the 1880s that we should metamorphose the concepts that we apply to inorganic nature, and in that way adapt them to organic nature. I will be discussing this further in the next few days. In this way, however, we also begin to see what the real driving or creative principle of organic nature is. To this observation, I would like to add something that will show that Anthroposophy does not underestimate the materialistic phase in the development of natural science, a statement I will comment on again in the next few days. Anthroposophy should see this materialistic phase of natural science as a transition, as a method of learning how to yield to the pure sensory experience. This phase was highly educational for human civilization. We can have a clear overview of certain things only after we have experienced this kind of learning. Only one who is armed with such a sense of science can observe the external material world and see how the external material world mirrors itself within us, if I may use this expression. The world, as we experience it in ourselves, is more or less an abstraction, an image of the external material world, interwoven with our senses and impulses of will. Thus, when we move from observing the external material world to observing the spiritual world, we come to the purely imagined. Let us hold on to this point. Externally, we have all the material phenomena that we observe in a phenomenological sense. Internally, we have the spiritual, the psychic, in a certain abstract form, in the form of an image. If, however, we observe with an anthroposophic worldview the things that spiritually are at the foundation of the external material world, if we enter the spirit that is active in the motion of the stars and in the formation of the minerals and plants and animals, then we enter the spiritual in the very coming into being of the external world. We come to know it through imagination, inspiration, and intuition, which also give us an inner image of the human. But what is this inner image of the human? These are our physical organs. They now correspond to what I had learned before as the nature of the sun, the moon, minerals, plants, animals, and of other things. This is what the internal human organs correspond to. We can get to know our own human organism only if we get to know the external world. The material world outside us is reflected in the spiritual and the psychic within us. And the spiritual world outside us is reflected within us in the forms of lungs, of liver, of heart, and so forth. If we look at our internal organs, we will see that they are in the same relationship to the external spiritual world as our thoughts and feelings are to the external material world. This demonstrates that Anthroposophy is not over-eager to reject materialism. But let us look at the entire range of sciences. We will not be satisfied with the results of thousands of them using the traditional methods. By contrast, Anthroposophy will achieve a worldview through its methods that does not leave us unsatisfied. It recognizes the physical material both in the inner organization of the human and in the phenomenology of the surrounding world. At the same time, Anthroposophy has to recognize that this inner organization is a result, a consequence of the spiritual in the cosmos. Therefore, it wants to complete what astrophysics, physics, or chemistry have achieved through mathematics alone. Anthroposophy will do this in the form of an organic cosmology, and it will continue to search until it brings us to a better understanding of the material aspect of the human being. Such methods are fundamental to the understanding that Anthroposophy can develop also in service to medicine, biology, and so forth. I hope that with these brief comments, I have pointed out why anthroposophy, if we understand it correctly, is not in opposition to contemporary science. Instead, it seems to me that contemporary scientists have not found the bridge that shows that anthroposophy strives to be strictly scientific with regard to natural phenomena.